Hey guys, okay, yesterday I gave you an opportunity to get used to lesson 110. Now lesson 112 is a continuation of lesson 110, just changing one thing. So now I am going to combine it with two lessons because you can do it. Okay, so here we go. Lesson 111 first, though, is easy. Okay, also something that you already know is just changing it a little bit. So that's why two easy lessons combined today just makes one perfect lesson. Okay, here we go. Look at 111.1. There were 26 nickels, dimes, and quarters in all. Okay, all of a sudden you know that's your quantity. Okay, your quantity, so I'm going to go nickels plus dimes plus quarters equals how many? 26, okay? You already see what's happening here. They're just giving you 3 instead of 2. And their value was $2.25. So look, if they've given you more than 2, they've given you 3, you're going to need how many equations? 3. So listen in for 3 equations. That's your quantity. We just got our value, okay? It's going to be what? 5n, because that's the value of nickels, plus 10d, that's the value of dimes, plus 25q, that's the value of quarters, equals 225, because I don't work with decimals. You guys know that already, right? But I don't go 0.05n, 0.10d, 0.25q equals $2.25. No. Everything we take off the decimals, okay? Then it says, how many coins of each type were there if there were 10 times as many nickels as quarters? What does that sound like? Another quantity equation. Okay, so let's do it. There were 10 times as many nickels as quarters. Think about that. How do you set that one up? Is it 10 times nickels or 10 times quarters? Well, which one has more? Nickels or quarters? There's 10 times as many nickels as quarters, so there's more nickels. So it's going to be nickels equals 10 times quarters, because how are you going to get more nickels unless you multiply it times quarters? There's 10 times as many nickels as quarters, so there's more nickels. Nickels equals 10 times quarters. Okay, that's how you're going to get that. Now that we have that cute little equation right there, everything else should be pretty easy, because what are we going to do? Rewrite our equations, substituting in substituting in 10 quarters. So here we go. I'm going to put this in here for nickels, 10 quarters here, and 10 quarters here. That's going to be 50 quarters. Okay, now I'm going to rewrite my equations. I'm going to write them down here. 10 quarters plus 1 quarter is 11 quarters, plus D equals 26. And then over here, it's 50 quarters plus 25 quarters is 75 quarters, plus 10D equals 225, right? So then I'm going to multiply this one by negative 10 to make D cancel out. So it's going to be 110 quarters minus 10D equals negative 260, right? Cancel that out. That's negative, pardon. Okay, now we have 110, pardon, you can't see that, huh? 110 minus 75 is 35. Okay, so 35, negative 35 quarters equals negative 35, right? So there's how many quarters? 1. Because you divide negative 35 and negative 35. So there's 1 quarter. Okay, guys, then that makes it even easier, because if there's 1 quarter, we do 1 times 10. There's how many nickels? 10 nickels, okay? And then we know up here from our quantity that it's nickels plus dimes plus quarters is going to equal 26. Well, nickels plus quarters is 11, so dimes must be what? That's 10. This is 1. Subtract that from 26. 26 minus 11 is going to give us 15 dimes. There you go. And you solved example 1. Okay? So, if they're asking for 3 things, remember how many equations you need. We need 3 equations. So let's look at example 2. The total number of blues, greens, and yellows in the pot was 7. Okay, here we go. Blues, plus greens plus yellows equals 7, right? The blues weighed 1 pound each. Okay, this is our value. 1 pound for the blues, 4 pounds for the greens, and 5 pounds for the yellows. The total weight was 25. Okay, and let's see what third equation they give us. There was one more yellow than green. Okay, one more yellow than green. That means there's more yellows. So it's green plus 1. Okay, one more yellow than green. Más que the green one. Okay, well then let's substitute that in for our y, right? G plus 1. And over here, okay, that's going to be 5 times g plus 1 is 5g plus 5, right? So then let's rewrite our equations. We have now 2g, and we're going to move the 1 over here to negative 1, right? So it's going to be b plus 2g equals 6, okay? Then this one over here, I'm going to minus 5. So that's 9g, 1b equals 20. Okay, so now they made it so easy for us because we can just cancel out those b's by making one whole equation the negatives, right? Which is what I'm going to do down. Let's do it on the top. Negative, negative, negative. So that's going to be cancel out our b's. We're going to have 7g equals 14. So g equals 2, right? Well, if g equals 2, then that's 2 here. That means y equals 3. And then b is g plus y plus b equals 7. So that's 2 plus 3 is 5. So b must be 2. Okay? Then you can check it by plugging it in. But that's your answer for example 2. So go ahead and try the practice and make sure that you can do that on your own. Okay, guys, so for the practice, your answers are nickels is 6, quarters is 12, dimes is 17, right? How? Well, the very first one says there were 35 nickels, dimes, and quarters in all. So n plus d plus q equals 35, right? The value is $5, so it's going to be 5n plus 10d plus 25q equals 500. And then the second one says there are twice as many quarters as nickels. That means that there's more nickels than quarters, so it's quarters equals 2 times nickels, okay? I substitute in the 2 nickels for both the quarters, and I rewrite the equation. 3n plus d equals 35, and 55n plus 10d equals 500. I multiply this one by negative 10 to equal negative 30n minus 10d equals negative 350. Combine those two to get 25n equals 150, so n is 6. I put that 6 into here. 2 times 6 equals 12 quarters, right? And then I put 6 and the 12 into this one to get 17 plus d equals 35. Pardon, 18 plus d equals 35. So 35 minus 18 is 17. Okay, so now we can move on to lesson 112. If you look at 112, it almost looks exactly like 110. However, here is the difference right here. I'm going to show it to you in example 1. This one has x plus 2 times x minus 3 is less than 0. So now, instead of coming up with greater than 0, that means that we need a positive number no matter what, right? Now, or we need a positive number over here, which was positive times positive and negative times negative. Now we need a negative number, which means that we're going to need a positive times a negative and a negative times a positive, okay? That's what we're trying to accomplish. So let's put that right here. We're looking for a positive times a negative and a negative times a positive, okay? Well, when we solve this problem, we're going to be coming up with a negative on both of these, right? Listen to me carefully. When we solve this, we're coming up with a negative on both of these. Why? Because it's less than 0. What do I mean by that? I mean that if I go to solve this one, I have x plus 2 is less than 0, and x minus 3 is less than 0, right? So both of these solutions are going to become negative. They're going to be less than 0. So I'm going to put one on one side to fulfill my negative and one on the other side to fulfill my 2 negatives. Those are going to be my easy ones, okay? So that means I have x is less than negative 2, okay? I'm going to put that on this side for my negative one. X is less than negative 2, okay? And then I have that this one is X is less than 3. And I'm going to put that one on this side to fulfill my negative. X is less than 3, okay? And then we do our little switch. So if I have X is less than 2 over here, negative 2 over here, I'm going to have X is greater than negative 2 over here, right? And then if I have X is less than 3 here, I have to switch it over here, and X is greater than 3, right? So while that part may seem a little like abstract and confusing, okay, remember this is only when it's less than 0 and not greater than 0. The next part is easy to figure out which ones then do we keep, because remember we can only keep 2. Well, look, this doesn't even make any sense. There are no numbers that are what? Less than negative 2 and greater than 3. There are no numbers like that. But there are numbers that are less than 3 and greater than negative 2, right? So this one we keep, okay? So on the ones that are less than 0, you have to keep you have to keep all of one side, okay? And the only part that's going to be hard with this, you guys, is remembering the differences between the two, okay? Separated from each other, they're easy. So what do you need to do? You need to train yourself to first thing is to fijar in this. If it's greater than 0, which means you're looking for a positive number, you need positive times positive and negative times negative, and you do the process that I taught you the other day. But if it's less than 0, it's going to be negative and positive and negative and positive. So you start out with putting your normal answers, one on each side, flipping them, and then choosing all of one side. So we chose this one. It's real numbers as our domain, so I'm going to put my number line. Negative 2 here, even though it's not included, and 3 here, even though it's not included, right? Less than 3, greater than negative 2. And we color in here. Okay? So let's look at example 2. Okay, example 2, obviously we're going to see that it is less than 0. So we're going to come up with positive, negative, positive, negative. It's integers, so be careful with that one. And look, the first thing you have to do is factor. Okay, I'm going to factor it as soon as I write it. So let's just do it. We need the factors of negative 8 that are going to add up to equal 2. I'm going to put my parentheses. Think about how you would do it in your head so you can compare it with what I'm about to show you. I'm going to do factors of 4 and 2, right? Positive 4, negative 2, because you want a positive 2 on the middle. Okay, so there you go. X plus 4, X minus 2. So here we go. I need my positive, negative, positive, or negative, positive. Doesn't really matter, right? So I'm going to put this one over here. Let's do X is going to be less than negative 4. And X is going to be less than 2, right? Because that's what happens if we solve for it. Over here, it'd be, move over and it'd be negative 4, right? And then move over that and it'll be positive 2. And then we flip it. We put this one over here, so it's going to be X is greater than negative 4. And over here, X is greater than 2, okay? Which one of these even makes any sense? Are there numbers that are less than negative 4 and greater than 2? No. But are there numbers that are less than 2 and greater than negative 4? Yes. Okay, and they're integers and they don't include the negative 2. They don't include the 2 or the negative 4. So I'm going to put here, I'll put the 2 to remind myself what it is, but it's actually going to start on 1, right? And I'll put the negative 4 here, but it's actually going to start on negative 3 because it's less than 2, greater than negative 4. And then we do negative 2, negative 1, and 0. Because you have to color all of them in to show what all they include. Okay? So go ahead and try to do practice A and B and see if you understand. Okay, guys, here you go for A and B. A looks like this, negative 4 to 1, and B looks like this, negative 1, 0, 1, 2, 3, 4. Okay, how do we get that? Well, on the very first one on A, I get X is less than negative 4, and X is greater than 1, x is less than 1, and x is greater than -4. I cross out this one because it doesn't make any sense, but this one is possible, greater than -4 and less than 1. It's real numbers, but the -4 and the 1 are not included, so you just leave them open circles, right? This one over here, I factored it out to x is -5 times x is plus 2 is less than 0. So you have x is less than 5 and x is greater than -2. X is less than -2. X is greater than 5. So I picked this one because that one's the possible one. X is less than 5 but greater than -2. Okay, but they're integers, not including -2 and 5. So I have them there but not colored in at all. Okay, looking at your homework today, if you look at numbers, let's see, 6, 7, and 8. If you look at 6 and 7, those are following the procedure of today, so that's going to be less than 112. But 8 is following the procedure of 110 because that is greater than 0, okay? So that will give you practice to make sure that you can differentiate between the two, and if you want to check your answers right away, just text me and we'll look them up for this lesson, okay? Bye, guys. Thanks.